Hi and welcome to our today video, which is about OpenStack and OpenStack networking. So today we will be looking at OpenStack, the open source cloud platform that can help us to build public or private clouds. And we will be reviewing that how the virtual machine or instances inside OpenStack, how they can communicate with each other and how they will be communicating with outside world. We will be looking at the neutron, how the neutron works inside the compute host, and also how the neutron works on the neutron gateway to provide external connectivity to the instances or virtual machines. And also we will be reviewing the overlay networking within the OpenStack host for providing the internal connectivity between the virtual machine or the instances. So let's start. All right, so to start with, let's have a look at the OpenStack website, openstack.org. And here we can just go over the software. And if you click on the software components, here we can see the different components of the OpenStack. So OpenStack consists of multiple different open source projects, which are all combined together to deliver the cloud function to be used as for a public or private clouds. So there are, it has one of the major components is the compute, which we have, the Nova computes, Gling, Zune. We have services for bare metal, the storage, the Swift object storage, Cinder, the block storage, and networking. This is the famous Neutron, which is providing the networking for the OpenStack. We got Octavia, which is a load balancer, software load balancer for OpenStack, and the other services which are mentioned. Now, since OpenStack contains multiple different software components, it requires a deployment tool to deploy and install the OpenStack on multiple different hosts or virtual machine or containers. So normally installing the OpenStack, if you want to do a manual installation of OpenStack, it may take a very long time, following a very complex installation documents to create, the storage and, the networking or the compute, it may take a very long time. So there are multiple different deployment tools available from OpenStack and also from the other companies who are working with OpenStack, doing products within the OpenStack. So these are the tools which are provided by OpenStack. They are sponsored here. So the first one is the O. So O is a project which uses OpenStack, a lightweight OpenStack. Normally it's called Undercloud, to deploy a the real production OpenStack, which is called Overcloud. So this is one of the methods. It's based on the Ansible. There are other methods like, it has also different Ansible playbooks for deploying OpenStack, and we have also this OpenStack charms. The deployment method which I have used for building this OpenStack platform for the demo is based on the OpenStack charms or Juju charm, which is listed here. When you try to deploy OpenStack with most of these methods listed here, you may face problems, face failures, problems, and fixing those failures and problems sometimes is not easy. You need to find a method which is more compatible with your hardware or your environment. So I found actually Juju Charms something compatible with my environment. So the platform which we have is based on physical servers. We have 4 physical servers in our OpenStack platform right now, and the others, you can also do physical servers with others. Also, you can deploy it on the virtual machine, single virtual machine or multiple virtual machines. But in general, you may face that the virtual machines are going very slow, and you may not get that performance from the OpenStack, which you are desiring to provide that performance. So if you go on the Juju charms, this one actually provides some basic information, and if we click here, OpenStack in Juju Charms, so this is the canonical Juju Charms, which is a method for deployment these all the components of the OpenStack. It includes all of these components, and if we just go to the OpenStack Charms here, and from here, what I have done, I have used the OpenStack base, and I have downloaded this file and followed these instructions here. So this deployment which I have is based on uses the mass, the metal as a service, so it automatically provisions my physical servers, and it automatically installs also the OpenStack. So it includes all of these components, and when you install the OpenStack, it also creates the relationship between the components. So let's have a look at what we have built. So let me just zoom this out a little bit. Okay, so this is our the diagram for today demo. So we have 4 physical servers right now in our OpenStack, and these 4 physical servers, 3 of them here, they are all Nova Compute nodes, and this one is a Neutron gateway. So this node will be acting as the gateway node for providing external networking to our OpenStack components and to this virtual machine which we are going to build. So we have all of our hosts here, they are all connected to a management network, the management LAN, and this network is based on these IP addresses which we have listed here. So all of them are in 192.168.251.0/24. That's a network for the management. We have these three green ones are virtual machines. So I have a Juju console, this IP address, I have a Juju controller, and we have a mass server. So the mass server actually does the provisioning the hardware servers. So it installs the base OS, it uses the IPMI or the BMC for turning on and turning off the server or booting them. And so only here actually we have only the Neutron gateway with another interface, another physical interface is connected to external network. So this external network has a different IP range, so it has 192.168.252.0/24, and it is connected to the internet. These servers which we have, they are all HP ProLiant DL380 generation 5, so they are pretty old. And when we start with mass, it installs the latest Ubuntu 18.04 LTS on all of these servers, and that just works because normally these servers, they are all the RAID controller, for example, is not supported in the newer versions of the Linux distribution, but Ubuntu 18.04, it includes all the drivers, so it just installs very, very easily. So here, what we are going to do is we get a little bit familiar with the OpenStack setup which we have done, and we will do a login to our OpenStack Horizon, the web interface. We will see how it looks. To start with, we will not creating a separate tenant, so we will use just a standard admin tenant just for this demo. And we will creating a new external network, then an internal network, and finally we create a virtual router to connect the external network to the internal network. So that router will be sitting between these two networks, and we start with launching an instance and allocating a floating IP for our new instance. So the new instance will be sitting in the overlay network inside this internal network. Actually, this internal network which I have listed here is this overlay network, and it will be having a separate network with separate different IP address which is not exposed to any of these physical interfaces. So this network actually just lives as an overlay network between all of these hosts. So when the virtual machine, so this particular virtual machine, if it is located on the server 7, and the virtual machine number 2, if it is located on server number 11, to communicate, the communication between these two virtual machines, it goes over these two servers using a GRE tunnel or VXLAN tunnel. So that's how it's called the overlay networking. So once we allocate the floating IP for these virtual machines, we will allow external connectivity to these virtual machines actually. So from external, we will be able to access through one of these IPs, which eventually gets destination NAT through the neutron gateway, and it will reach to the virtual machine. We will have a small little deep dive into the neutron gateway to understand how it really works, how it provides external access and internal access, to our virtual machine, to our instances. And finally, we will check the networking between these two instances. So once we launch these two instances, we will check how they are communicating between each other. So using those tunnels, which I said, like GRA tunnel or VXLAN tunnel, we'll review that, how exactly it is going to happen. So OpenStack, mainly the networking technologies, the open source networking technology, which we already studied. Most of them are used like Linux bridges or Open vSwitch, OVS. They are all using OpenStack. And even there are optional components like load balancer as a service or firewall as a service. For example, the load balancer as a service component of OpenStack, which we are not going to see it here, but that component is just based on the HA proxy, which we already studied in this course, which is an open source load balancer. And also similarly, it has components like firewall as a service, and the other components. So let's start jumping and looking at our OpenStack services, and start by getting into our web interface of the OpenStack. So I will start by accessing to this Juju console at this IP address which we have 192.168.251.3. So from here I will be able to find the IP address of the Horizon web interface. So Horizon, and all the other components, they are all running inside these servers. And also these servers are not only running a specific application, but they are also running few controllers as a container, as LXC container. So let's access this the Juju controller, the console. So let me SSH to this IP address, and here we go. We are on the Juju. So if we issue this command Juju status will give us information about what is going on. So we have different application of the OpenStack, which are all showing active. That's great actually. And we have the units. So this application, they are running multiple units. And so for example, we have multiple Ceph monitoring, Ceph OSDs, and the others like the Nova, the Nova computes, Nova Compute 0, Nova Compute 1, and Nova Compute 2. Here it shows the machine. The first digit is the machine number. So here actually we have 4 servers, so it's starting from 0. So this one, Ceph Mon 0, it is running on server 1 LXD 0. So the first container which is running on the server number 1, or this one is running on the server number 2 as the first container. Similarly, there are all the other OpenStack projects are listed here. For example, our Keystone is running on the server number 3 as the container number 1, the second container. We got MySQL, Neutron Gateway is sitting here. So Neutron Gateway, which is an important one, which we need to do some work with, that is running on the server 0. That's a physical server. And these are all the machines which are within this setup. So in total, we have 4 servers. So server 0, server 1, server 2, and server 3. And each one also is running 3 containers for running the whole OpenStack setup. Now to start with, we need to access to our OpenStack dashboard or the Horizon. So OpenStack dashboard is running on the server number 3, container number 2, but we don't care about that. We just need to grab the IP address. So 192.168.251.241, which is listening on port number 80 and 443. So let's get our browser. Let me close this and we just go here. Oops. Oh, okay. I put the wrong IP address, sorry, because I did not copy that IP address here. So the dashboard is this one and 251.241. And we have to specify /horizon. And here we go. We got the OpenStack login page. So this is OpenStack Rocky, the latest version of the OpenStack, which has been deployed here. Now we need to enter the domain, username, and password. Now to get the username and password, the easiest way is to, if you remember when we were doing the deployment of this OpenStack base, there's a file which we have to download. So this file, this zip file, includes the readmes that what you have to do. These are all the that readme file actually is listed here. How you can expand horizontally and how the installation in general has to work. There are three different files for the OpenStack RC. So you have to source the OpenStack RCs, which are actually doing some exports and setting some environment variables on the machine, which will allow you to use the OpenStack console for talking to the OpenStack on that machine. So on the Juju host, I will use that. I will source these I will source only this one, and I can find also the password for the admin user. So here, let me just I have put it inside this folder, the Juju bundle, and as you can see, we have this OpenRC here. So I will source OpenRC. Okay, so that is done. Now if I issue a set and just filter anything starting with OS or includes OS, now these are the stuff which are added by sourcing the OpenRC. Now I have the project domain name, admin domain. So this is the domain which we have, project name, admin, the region username is admin, and this is the password. So the clear text password is here. I've copied it already. Now we will go back here, to our login page. Okay, and let's try to log in. So the username we got was admin, and the password is the one which we got. And we just click on sign in. Okay. All right. So now we are in our OpenStack. It gives us the dashboard. We have 0 instances. We don't have an instance running. The virtual CPUs, the memory, 50 gigabyte of memory we have in total, which we can use. So it's just a fresh OpenStack. Here is the compute. Let's go to the network topology. We should not have anything here. So there is no network, no routers, nothing is there. So let's start with creating our external and internal networks. So let's go back to our drawing here. So we managed to log into OpenStack using the Horizon Web GUI. We got the password from doing the sourcing of the OpenStack OpenRC file. We will create an external network and we will create an internal network now. So the external network is be connected to the external and the internal network here. So let's go back to our networking. Let's go to the networks and let's start from here. So we create a network. Let's call this network as internal network. Okay, and this network requires a subnet. So we create a subnet. We call it internal subnet. And let's say, okay, so we need a network address for our internal network. let's see what we were thinking of. So 10.5.5.0/24, that's the address we are going to use for our internal network. So 10.5.5.0/24. So you can use these hints also, which is located here, for getting information. There is no gateway IP here, so we don't need to do anything for that. And click. We will be running. We will keep the DHCP server enabled. So this network actually will serve as a DHCP server for all of these new instances or virtual machines that we are creating. And we need to create a pool. So to create a pool, we just need to say start IP, comma, the end IP. So let's say from 10.5.5.100 up to 10.5.5.150. We need to provide a DNS server. So, and what's the format? The format is 1 entry per line. So let's say 8.8.8.8 and 4.2.2.4. We don't need to have any host routes, and let's create the network. Okay. Now our network, the internal network, is created already. If you go to the topology here, we can see our network showing just like a line here. Okay. Now let's create an external network. So we create another network, and this network will be shared because we will be using it for other tenants probably also in the future. We call it external network, external net. Next, and the subnet for this one is external, again, subnet. I can only call it this 252. The network address is 192.168.252.0/24. Here we have to also mention the default gateway. So this is an external network. So the default gateway actually on this network is 192.168.252.1, which is a router which we have here. So that router will be the default gateway for our neutron gateway in order to route out towards the internet and to the outside. So let's add that IP address also here, 192.168.252.1, and we are not going to run the DHCP server here. So okay, so we just click on create, and here now we have two networks created, one internal network and one external network. And if you go on the topology, we have the two networks sitting here. And these two networks, they don't have any connectivity between each other. So we have external network and internal network. And, you know, now to connect these two networks to each other, we need a router in between. We need a router. So we have to create a router to connect these two networks to each other. Let's go on the routers. And here we will create a router. Let's say a router. We create a router. We click on set gateway because we want our router to do the NATing. Oh, here actually it's not showing anything. I think we have made a small little mistake somewhere in our external network. So edit the external network. All right, okay, so actually we are in the project level. We have to make this network as external, we have to go in the admin, and so let's try to do it from here. So admin networks and our external network. Let's edit this. Yeah, so we can enable the external network here. Okay, now again at the project level, we go back to the project level and we go on networks. So we can see this one is external, and let's create a router here now. We already created the router. We click on set gateway, and the gateway will be our external network. and we enable the source NATing. So this router will perform source NATing over the external network. Now the router will have a single interface because we already selected that. So we have an interface, and it already got some IP address also. So 192.168.252.4. So this is the IP address allocated for our router interface. Let's add another interface because the router requires another interface on the internal network. And we can add optional IP address also on the internal network, which we don't need that. Okay. All right. Now, as you can see, our external gateway status is active. This one is 10.5.5.1. It still is down, but it will come up very soon if we just refresh that. Now let's go to the network topology. In the network topology, let's see what do we have. Okay, now we got this router between these two networks, and so which is connecting your internal network to the external network. As you can see, the router has got two interfaces, and it shows all of this information. It's a nice, good demonstration of what we have created here. So now we got internal network, we got external network. Let's see what else do we need to do. We created the virtual router gateway to the external network. Okay, now we have to launch an instance. We will launch an instance, and an instance will be created to our internal network, to this one. And let's have a look. So we will go to compute instances, and we will see we don't have an instance running. We will click on launch instance. Before I launch instance, you need to load images. So here I have already loaded the image file. It's a cloud image of Ubuntu 18, which is already loaded there. So the image, the instance which we are creating, it will be based on, this image. You can load other images also, CentOS, or any other application also. You can load it here, whatever it supports. For example, you can load the Qualys vulnerability scanner also as a virtual image here. So I can either just launch, or I can go to the instances and launch. So I will use this one, the instances, and I click on launch instance. Let's call this VM1, and it is our virtual machine 1. We are going to launch one of them only. Let's say 5 GB of disk space, and the image is going to be this one. This is the Ubuntu 18. So I selected the image, 5 GB, and this is our the source image file. Flavor, we have already a flavor created, M1 small, which includes 2 GB of memory, 5 GB of root. Let's continue. The network that we are going to connect this virtual machine, we can connect it also on the external network, but we will choose the internal network. That's what we are planning to do. Network port is not required. Security groups. So security groups by default, this is like a firewall on the virtual machine. I have modified the security group. Actually, it allows everything, but by default it doesn't do much, so it's not allowing stuff. So I have allowed ICMP and other protocols, also the TCP22, which is the SSH, also is allowed inside this security group. Key pair, this is the SSH key pair which I have, and by default when the instance launches it comes with this SSH key, so we can just log into the machine without any username and password. We don't need to do anything else. We just click on launching the instance, and here in the web interface we will see that the image is being built. So it goes to 3 or 4, I think, different states, block, device mapping, and a few other states. So it already allocated the IP address for our virtual machine 10.5.5.105. So now we have the virtual machine has got the IP address, and this IP address will be allocated inside the machine. So let's wait for it to become active. Okay, so now as you can see, the status is active and the virtual machine is running. And it is having this particular IP address. Now to access our virtual machine, we need to have another IP address here because we don't have any route to these IPs, right? These IPs are all within the OpenStack, and we are sitting somewhere here outside, and we don't have any access here. So we need to do some mapping. We have to access to this external network, and from external network we jump into our this virtual machine number one. So this is called we allocate the floating IP here, and this floating IP, which is inside this external LAN, that will get NATed, destination NATed through the neutron gateway, and it will be sent towards the virtual machine one. So here we are going to allocate a floating IP for our new instance. So we will go back here and we will go to the network and floating IPs. So here we can allocate IP address to the project. So 192.168.252.6 is allocated, and we associate this IP address to our VM1, virtual machine one. So we allocated a floating IP and we assign it to our new virtual machine. Okay, and now it is showing active. So our floating IP address is mapped to this IP and it is showing active. Now let's try to access our virtual machine through SSH. Okay, so now let's first try to ping the floating IP, which is, so I'm just trying to do it from the same Juju console. So 192.168.252.6, which I'm able to ping it. So this is actually the virtual machine replying to the ping request, but the Norton gateway is doing a NAT translation. And I should be able also to do an SSH as Ubuntu, because Ubuntu is the default username, set for these machines. And I used my keys. So now we got Ubuntu @VM1. So this is the VM1, this virtual machine. And we are connecting from outside, coming to the external network using that floating IP address, and Neutron Gateway is doing a NAT translation, doing a destination NAT, and we are entering from here, going over the overlay network from the server number 9, doing overlay, I think using a GRE tunnel to the server which is running our virtual machine number 1. Okay. Now on the VM1, if I do, let's see. So we got a network card ENS2, one single interface, and let's see what IP address we got. And this is the IP address 10.5.5.11. That's the IP address of the machine. And from here, I should be able to access the outside also, which I do have. So I can access to the internet, and the Neutron Gateway is doing the NATing for us, allowing this virtual machine to go out. Okay, let's see where we have reached. So we allocated this floating IP for the instance. We check accessing the new instance using the floating IPs. Now let's have a look at the Neutron Gateway to see what exactly going on here. So this will give us some clarity that what exactly is happening. How we are able to access to the internet. Let's see where the VM1 is running. If we go to our instances in the compute instance, and we should be able to see the VM1. If we click on the VM1, it should give us some information. So VM1 it's running on the host server number 10. Actually, it's sitting on the server number 10. And server number 10 is this one, with a different IP address. So we are coming here and we are going over the overlay. Actually, it's server 9. The Neutron Gateway is doing a GRE tunnel between server number 10 and server number 9. That's how the communication happens for the external access of these virtual machine. So our VM1 actually is sitting here, and this is dynamic. So every time you launch some instance on OpenStack, it just decides where is the best place to load and run this virtual machine. So for us, for this time, the VM1 was placed on the server number 10. Okay, so let's have a look at the server number 9, the Neutron gateway, and see how the communication is happening. Okay, so let's get out of this virtual machine now. We are again back here. So we are going to have a look at the server 9, which is 192.168.255. So let's SSH to 192.168.251.1, sorry, .235. Okay, so we have to say Ubuntu because this machine was deployed using mass, and it has loaded the default user as Ubuntu. Okay, so this is our Neutron gateway. If I do system ctl grep OVS, you will see we got a few OVS services which are running. Neutron OVS cleanup, OVS vSwitchD, and the others. And if I do Neutron, so we have Neutron L3 agents, Neutron load balancer as a service agent, metadata metering, Neutron OVS, and the others. They are all. Now, if I do an IP link, you will be surprised with number of interfaces which are all in this machine. So we have the loopback 0 and ENP3S0 and ENP5S0. So these two are physical interfaces. This one is the physical interface for the management network, and this one is the physical interface connected to that external network. So ENPS0 actually is this one. So better ENP5S0, and this one is ENP3S0. So we have two physical interfaces, and we got lots of bridge interface, virtual interfaces, and virtual Ethernet, virtual patches, all within this. Let's see, what do we see as IP address? And we got a bunch of interfaces with we get IP addresses also. But if you look at here, we don't see those IP addresses here, right? So the IP addresses for the virtual interfaces, that overlay network which we created, they are not here. So I have, for example, only 192.168.251.235, which is the IP address of the server, but we don't have anything else. So where they are hiding is, we have to look at our network net spaces. Now we have two net spaces here. We have a DHCP and we have a Q router. So this is the one actually which Neutron creates and places all of those, creates actually that virtual router which we created inside Neutron actually is created inside this new network namespace here. And let's see, what do we have here? So if we do IP net space exec on this one, on the router, paste, and we say IP address, and we have to do a sudo. Okay, now we got very few number of interfaces, and we have this one, and we have 192.168.252.22. So this is the IP address actually on our external interface. And this one is the IP address of our virtual machine, the floating IP. So each floating IP is being configured on, this dynamic interface as a /32. And Neutron gateway will do the netting, from here to this network. So this other interface which we have actually is our internal network. So we have 10.5.5.1. This is a default gateway. This is the virtual router, the default gateway of that interface, the interface of the our overlay network. So all the virtual machine traffic will come as a default gateway here, and this router will do a source netting to go outside. And for the return traffic, if someone needs to communicate to the floating IP address here, again, the virtual router will do a netting between this IP and the IP address of the specific virtual machine and allows it to reach there. So if I do a ping to our virtual machine, let's see, what was the IP of our virtual machine? The VM1, here we go, is 10.5.5.11. If I do a ping to 10.5.5.11, it will not ping that IP because this is inside that overlay network and we are just on the standard default network namespace, so we will not be able to reach there. So to be able to reach to that virtual machine only on this neutron gateway, we can say IP nets, let me do this way, yeah. IP network namespace execute on this particular namespace, which we know that this is the namespace that the internal network is sitting there. Then we can say from this net space, try to ping to 10.5.5.11. And I have to do a sudo. Yeah. So now you can see we can ping that particular virtual machine. And this virtual machine is not here. It's not on the server 9. Actually, it is on the server number 10. But how they are communicating with each other? So from server 9 to server 10, so this communication is happening over a GRE tunnel. So if I do again IP link, you will see we got these GRE interfaces. Let me do a grep of GRE. So you can see we have multiple GRE interfaces where I think probably this one is being used for that communication because this is down, and this one is not down. So that's how this communication is happening. And I should be able also to do SSH from this command here. And okay, so from this machine I don't have that key, so that's why I'm not able to reach to the server. I cannot do the SSH, but that's fine. So this is how the IP addresses are configured here. Now if we do vsctl show again with sudo, now we will see more interesting stuff. Here we go. We got something called bridge external. So we have a virtual switch on the OVS created here named br-ex, and this one, it has a 5BREX. It's a virtual patch connected to something called INTBR external. So this is a connectivity between the bridge external and bridge internal. So actually it's connecting here, and we have the port ENP5S0. So ENP5S0 is our physical interface connecting to the external network. So this port is also within this bridge. So we have a virtual switch which our external network is connected here, and also it has a patch cable connecting to the bridge internal. And bridge internal, it has all the other stuff like this connectivity to these tap interfaces, connecting to the this patch ton, So and also on top of this, I think we should have some, we have some Linux bridges as well, which are created by the OpenStack. This part, actually, there's a nice diagram inside OpenStack. If you see here in in a machine we got Linux bridges. So the virtual machines, they are all connected to through a Linux bridge, and these Linux bridges, they are all connected again with these virtual Ethernet pairs to this bridge internal br-int. So this is in the OVS. I see this is red, and this is inside the OVS. And the bridge internal again is connected with this virtual patch interface to bridge external. So, and this is how the communication is happening. So OpenStack actually uses both the Linux bridges and also OVS for providing the network connectivity between the machines. And it may use the GRE tunnels or VXLAN tunnels for providing this network access between the servers. If you see here, these machines, they don't have these IP addresses. So when we are talking about the GRE or VXLAN, so for example, when a packet arrives at the Neutron gateway, and this packet needs to go, for example, to the VM1, which is in this network. So server 9 doesn't know exactly where this VM1 is located, so it will query inside OpenStack. It will find out that where this VM1 is sitting. So OpenStack will tell to the Neutron gateway, hey, this VM1 actually is located on the server number 10. Then the Neutron gateway, the server number 9, it establishes a tunnel, either using GRE or VXLAN. It sends all of these packets, the main packets, encapsulated inside another packet to the destination IP, to the 192.168.251.236. So that's how the overlay network works. And if this particular virtual machine is sitting somewhere else, again, it will find the IP address of the host that virtual machine is sitting on, and that traffic will go encapsulated to that particular host. So that's how the Neutron gateway actually works. So now let's try to launch another instance. So we create the virtual machine 2, VM2, and we see what IP address it will get and where it is going to sit. Okay, so back to our OpenStack, and let's launch a new instance. So we are going to launch new instance, and we call this instance VM2. Let's say 5 GB of this. This is the image. Use this flavor with 2 GB of memory connected to the internal network, and just a launch instance. Let's give it a few seconds for building and starting the VM now. Okay, so now we got the virtual machine running, and it got this IP address 10.5.5.4. And we haven't assigned any virtual floating IP to this machine, so we keep it isolated, and we will see how we can jump to this machine from VM1. So we have access to the VM1 through this floating IP. Let's try to do that, and from there we will jump to the VM2. For doing that, let's have a look at where these machines are running. So VM1, we know it's running on server 10. The host is server 10, and VM2, let's see where it is running. So this one is running on server number 7. So two different servers. So this is where the VM2 is running on the server 7, and VM1 actually is running here on the server number 10. So now let's go and let's try to, so I'm currently on the server 9. Let me get out of here, and from here I will just jump into the floating IP of the virtual machine 1, which was 252.6. Okay, now we are on the VM1. Now if I do, my IP address is 10.5.5.11, and I should be able to ping 10.5.5. What was that? 5.4. That's a VM2 IP, which I can. So from VM1, we are just pinging VM2 it is exactly like they are sitting on a layer 2 network, but actually they are in they are on a layer 3 network. So from VM1, which is sitting on the server 10, to the VM2, which is sitting on the server number 7, and there is no layer 2 connectivity between these two for this particular network, we are doing encapsulation. So Neutron is doing the encapsulation for us between these two. And SSH from here. So if I do SSH to 10.5.5.4, okay, we don't have the keys actually. We don't have the keys loaded here. But let's see how it is happening. So let's have a look at the server 10 on this IP. Let's check what is happening on the OVS and the network namespaces. Let's see what's going on. So let me exit from here and we do an SSH to as Ubuntu. So now we are sitting on the server number 10. Let me do a sudo -s and OVS OVSCTL show. Let's see, what do we have? So here we have got the bridge tunnel. This is another. We have bridge data and we have bridge internal. So different virtual switches has been created using the OVS. And if I do, let's see, do we have multiple namespaces? No, we don't have any multiple namespaces. If I do an IP address, it seems very complex. So let's do just grep finet so we see the IP addresses. So we have our management IP. So this is the management IP, and this one is for the LXD bridge. So this is the network for the containers which are running inside this host. There are a few containers also running here. So the machine actually used this IP for doing encapsulations using GRE tunnels to the other server. That's how they work, and using this the OVS. Similar setup also we have on the server server number 7. Let's have a look at the server number 7 as well. Server number 7, its IP address is 237. IP address of 237. And now we are on the server 7, and here also if we do, let's do a sudo-s OVS VSCTL show. Again, we have similar kind of setup. So we have bridge data, we have bridge internal, bridge external, and also we have the bridge ton. So this bridge is used for doing the GRE. Oh, here we go. So we have a GRE port with the GRE type, and the local IP address is this, and remote IP actually is the 236. So this particular port, this particular interface is like a virtual patch cable, which is connecting 237, the server 7, to the server 10. So all of the communication between server 7 and 10 for all of those virtual machines is happening on this particular interface. And we may have some more. So like this one, this is another GRE tunnel as a virtual patch cable, which is between the server 7 and 235, which is our server 9, which is our Neutron gateway. So any traffic from the VM2 going out to the internet, it will follow this particular interface. And as much as, you know, if you have more hosts within this network, and you know, having virtual machines also on those hosts, where any virtual machine on this host needs to communicate to them, we will have more and more of these ports added to this bridge ton virtual switch. Okay, so this is how we did actually the networking between the two instances. So this is how the traffic over this overlay works, you know, using those GRE tunnels within that bridge ton of the OVS. So this was our networking demo with OpenStack for today. So if you want to bring up your OpenStack, again, I suggest you get few physical servers. Try to build your OpenStack on physical machines to give it some more power. And as you see, OpenStack, it beautifully uses all of these open source networking tools like OVS or Linux bridges, creating these amazing GRE tunnels between these hosts or VXLANs. And you can do all of this testing with OpenStack. You can build your OpenStack in a virtual machine, or using a few containers. There are multiple different methods for bringing on and testing the OpenStack, or you can use on a physical servers. You can build your OpenStack in this way. You can create multiple different tenants, and the tenants will be isolated from each other even if they are located on the same host. So they will have different separate virtual bridges in the OVS, so they will not be able to see each other traffic. Their traffic will be isolated, and you can do all of this testing in your lab with OpenStack. So this was our demo with OpenStack networking. If you have any question, please either contact me directly or you can raise it in the forum. Thank you very much.